All right, what's up, guys? I'm going to do this quick video for you to help you a little bit with the Lewis dot. So I want to accentuate a couple things in this video, first of which to differentiate between ionic and covalent bonding. And you need to be able to decipher between the two when you look at a chemical compound, especially for tomorrow's quiz. So I would suggest trying these first on your own. So just pause the video when I put the compound up. And then afterwards, I'm going to go through exactly detailed steps on how we're going to solve and create a correct Lewis dot. So first one I'm going to put up there, CO2. So right now, pause it, try to do CO2 on your own. Try to do the full Lewis dot, the full equation like we do. And then whenever you're done with that, then turn it back on and I'll go through the steps. All right, so CO2. First thing we need to look at and realize is, all right, what kind of compound is this? Is this an ionic compound or is this a covalent compound? Because we need to know whether we are sharing electrons or whether electrons are being transferred, right, or taken. So we see carbon and oxygen. Carbon is a nonmetal. Oxygen is going to be a nonmetal. So we know now this is a nonmetal and a nonmetal bond. So that is going to give us a covalent bond. And so we are going to be sharing electrons. So we take these, find my eraser here. We're going to take this and let's go ahead and go micro with it, break it down. Carbon plus oxygen plus oxygen. Okay, so next, let's throw our valence electrons on there. So we have 4 for carbon, so 1, 2, 3, 4. And the placement of that is actually pretty legit because carbon with that tetrahedral bonding, it does like to have 4 different bonds off of it. So kind of placing it all the way around instead of pairing them up, you're not going to see a lot of lone pairs on a carbon. So we come over here to our oxygen, so 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. All right, so just for purposes of having all of this in front of us and following the same procedures, because remember, follow the same steps, follow the same procedures every time to increase your accuracy, right? So let's just make a little quick chart down here with my carbon and my oxygens here. So I have O2, we have 2 oxygens. So I have 4 electrons there with my carbon, and then for my oxygen, I have 6 per oxygen, so that's going to be 12. So 4 plus 12 is going to give us 16. So we're going to have 16 total electrons at the end. We need to make sure to verify that we haven't added or not used enough when we do our Lewis dot. All right, so let's bring it on over. And now, the next thing, we've already determined it's covalent, so we know we're sharing. But the next thing we need to determine is placement, because I know placement can be kind of annoying when we don't know where to put what. So think about this for a second. Who needs what? We know that we're both going to be getting 8 with both, or all 3 really are going to get 8 valence electrons shared. But who needs what and where is everybody at? So we know that carbon has 4. It's going to have to get 4 more electrons to get 8. Oxygen already has 6 both there and there, so we're going to have to at least have 2 more electrons added to get our octet there. So since this may have more bonds just off the top, and remember, it's okay if you place it the wrong way. You can always erase and go back. This is a is a trial and error sometimes as you're developing your skills on these Lewis dots. So I see there's much more diversity with these 4 valence electrons around my carbon, so I'm going to throw that in the middle. Okay, so I'm going to throw that carbon right here in the middle, and I'm going to flank it with my oxygens about on both sides of it. Okay, so now. Okay, sorry about that. I had something on the radio I had to handle. All right, so we're back here with our elements on the product side. So next, let's just go ahead and throw our valence electrons on over here. And again, we can, unless you're seeing this, which most of you are still developing and learning on this, so you're not exactly seeing the bonds pop out at you and you can just go ahead and throw them on. Put your electrons on there first. Don't try to skip steps. One step at a time. Take it easily. Take it, methodically, and the same thing every time. Routine, routine. You got to get a routine. So I'm going to throw them up here. So 1, 2, 3, 4, 5, 6. I'm gonna put my 1, 2, 3, 4 there, and 1, 2, 3, 4, and 5 and 6. Okay, so now I'm looking at this and I'm saying, okay, I've got to get 8 on everything. I need to, but again, just go one at a time. Try to focus on one pair, one oxygen and carbon, and see if you can get one of them to 8, and then we can progress and see where we're at. Okay, so we'll start here. We got 6, so let's start off. Always start with a single bond, then you can work your way up if need be. So we'll take 2 electrons. I've already got one right there, and I'm going to take one from the bottom here of my oxygen. Go right here. And we'll circle that up. All right, now count them up. Every time, count them up. You've done a bond. Now let's see where we're at. So 1, 2, 3, 4, 5, 6, 7. So now I'm at 7 with my oxygen. For my carbon, I'm at 1, 2, 3, 4, 5. So I'm still a ways off with my carbon, but I'm getting closer with my oxygen. So let's ramp it up to a double bond now with my oxygen and carbon. So I'm going to erase that one and erase that one. And I'm going to come up and I'm going to throw them right there. Circle them in. All right, let's count them up. 1, 2, 3, 4, 5, 6, 7, 8. Boom. So I'm golden now on my oxygen over here on the left. So I'm set. All right, let's check in on my carbon and see where I'm sitting there. 1, 2, 3, 4, 5, 6. So I'm getting closer now to where I need to be with my carbon as well. So now I'm going to come over to my oxygen, my last oxygen, and start working on the bonds between that carbon and oxygen. Again, let's start with a single, okay? So we got one sitting there ready for us. We'll erase the one at the bottom with my oxygen. Put that right there. Bond it up. All right, let's count them up. 1, 2, 3, 4, 5, 6, 7. I'm close. 1, 2, 3, 4, 5, 6, 7. I'm close. So now I'm close with both of them, right? So again, it's a progression. Let's continue to progress, single to double, right? So let's come over here and let's grab this electron right here. Let's take that one right there. Let's throw them in the middle right here for this bond. All right. And now let's count it up. 1, 2, 3, 4, 5, 6, 7, 8. Solid. 1, 2, 3, 4, 5, 6, 7, 8. Golden. So now we've accomplished it. We've gotten everybody their 8 valence electrons. We see that we have 2 lone pairs here on my oxygen. So we'll just take these and spread them out a little bit. Right here and right here. All right. And again, last step we're going to do, we need to go ahead and make sure that we only have used 16 because that's the total amount of electrons that are involved in this whole process. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. And that matches our 16. And we're good. Okay. So that's our sharing. That is our covalent, and that is carbon dioxide, which is super important to us. We're breathing that out, part of our atmosphere as well. So now let's get on to the next one, all right? Okay, see what we got next. Okay, so we've got beryllium and we've got bromine. So beryllium and bromine. So again, first thing, before we go any further, just pause it real quick, try this on your own, follow the same steps, identify what kind of reaction it is, then start doing your own Lewis dot, try to get it all handled with your electrons, and then once you've tried it, you can unpause the video and I'll walk you through it. Okay, so beryllium, bromine. So what kind of elements are these? Before we had a nonmetal and a nonmetal, which tells us it is a covalent bond. Now we have beryllium and bromine. So beryllium is an alkaline earth metal, and that is, of course, a metal. Then bromine is going to be a halogen, so that is a nonmetal. All right, so we now have a metal and a nonmetal. So in your mind right now, the bell should be going off. All right, ionic. So what comes with an ionic bond? It comes with a transfer of electrons, not a sharing of electrons. So even though it's still a bond, we now have ions. We have charges to account for, and we are going to be doing this process a little bit different, but we still are dealing with electrons and where they're going. So beryllium, bromine, let's do it. All right, let's break it down. So beryllium plus bromine plus bromine. All right, remember that subscript is telling us how many atoms are present on that element. All right, so beryllium being an alkaline earth metal, that's going to have 2 valence electrons. Bromine being a halogen is going to have 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. So now, this time, instead of making a chart and all that, you can make a chart if you want, and you can do that. But here we're not sharing electrons, and it's not as complicated with our electrons. So we're just transferring electrons here. So I'm going to now go ahead and put my yield sign on there. And with this, you can, again, notice what's giving up, who's close to 8, who's taking. So beryllium, of course, is going to be giving up its 2. It's not going to pick up 6 electrons to get 8. And it's a metal, and metals are going to be our donators of electrons. We already have 7 on both these, so we know we're super close to the ocho. We've got to just get those 2 electrons over. So we're going to throw beryllium in the middle here as more of our central atom. So we'll put beryllium right here, and then we'll put our 2 electrons right here and here. Well, actually, let's do this, make it a little easier. We'll throw one on one side, one on the other. All right, now let's start with bromines on there. So I'm going to put my bromine down here and my other bromine right there. All right, make sure that's in frame still. Sweet. All right, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so now no sharing, no covalent here. This is coming over, okay, and then this is coming over. All right, and so now our end product here is going to be, we can keep it like that, but let's just clean it up a little bit, get the arrows out of the way. Let's just move it over, and here's going to be our end product right here. So now we have beryllium by itself. Its electrons have been taken by our bromines, and now my bromine is over here, and my bromine is over here, and it's satisfied. It's happy. It's got 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So the only thing left to do is we know ionic bonds are from ions. We have ions here because electrons have moved. So now ions indicates a charge. So we have to throw that charge on there. And remember, guys, and I think most of you are pretty good about this, but remember, the charge of an electron is negative. So if you are getting an electron, you are becoming negative because now you have more electrons than you do protons. So you have an overall negative charge. And the opposite is true of somebody giving up electrons. So now you have lost an electron, you have more protons than electrons, and you are positive. So beryllium gave up 2 electrons, so it's going to have a 2 positive charge on there. And a bromine, both bromines here, they both picked up an electron, so they're going to have that negative charge on both of them. And then there it is. There's your Lewis dot for that ionic bond. So the process, guys, follow the process, follow the same steps every single time. Don't rush. Don't try to take shortcuts. Look at what you have, assess what you have. What kind of bond is it? What's involved? Is it metals, non-metals? Is it non-metals and non-metals? What is it? Remember, just go to your periodic table. We talked about these trends. We've learned these trends. So the right side, over that right side is your non-metals. So you need to identify what you are dealing with at the beginning. Then once you know whether it's being taken like this ionic or shared in a covalent, then you can start moving forward from there. Okay, so those are the 2 I'm going to do for the main one. I'm going to do a quick challenge one for you. If you feel like you're in a good spot right now and you want to challenge yourself with something a little more difficult than this, I mean, obviously it's not like, the pinnacle of difficulty here, but at the same time, it is a little bit more difficult. We're throwing a few more atoms in there. So if you want to challenge yourself at this point, then I'm going to throw this up here on the board. H2. All right. So right now, there's your challenge to try to knock this out. Go ahead and pause the video. And remember something. Remember, when you look at something new and you have something that's a little bit more difficult and you start to freeze up, all right, you're like, oh, I don't know what I'm doing. I don't know what I should do next. And you start freaking out because nothing is immediately coming to you. Rely on your routine. Rely on what you're doing every single time. Remember, it's a process. If you skip steps in your process, then you are going to be diminishing your precision on doing it the same way every single time, right? So make sure that you follow your process. And it's okay to be wrong. Just try it. Just try it. We learn from our mistakes. And these mistakes will lead you to the correct procedures and the correct techniques on doing these Lewis dots. So pause your video right now, try it. Whenever you have tried it and you've done your best on it, then you can unpause and we'll go through it. Okay, so here we go. We got 3 elements present in this compound. So we have hydrogen, we have sulfur, and we have oxygen. Now, first thing, let's follow the steps here. The first thing we need to determine is this covalent? Is this ionic? Okay, so hydrogen is not a metal, so we know that's a nonmetal. Sulfur, also nonmetal. Oxygen, also nonmetal. So we have a covalent compound here. So immediately, first things that should be popping in your mind is that, hey, we've got now we need to determine how many electrons each one of these has for valence, and we need to then start our whole process. So we know we're sharing, we know we've got covalent bonds. So right down here, let's make our chart real quick. So hydrogen, sulfur, oxygen, O2, we're adding. All right. Circle right there. Let's go ahead and get micro on our formula. So we have 2H plus H plus S plus oxygen plus oxygen. Okay, so now let's count them up. We have 2 hydrogens right here for H2, so that's going to be 2 electrons. We have sulfur, which is going to have 6 valence electrons. Then we have 2 oxygens at 6 a pop, so that's going to be 12 right there. So 12 plus 6, 18 plus 2. So we have 20 total electrons present. All right, now here's the thing. When you're looking at these actual elements and what they have and what we need to get, that's going to really help you in this instance. And I'm going to give you a couple tips. So let's go ahead and throw our valence up here. 1 and 1, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And again, if you prefer to go all the way around with your valence, go for it. So what do we have? We've got 6, 6, and then a 6 here. So we each one of them are equidistant away from 8, getting the ocho. So these obviously are hydrogen. We know that hydrogen's not going to get 8. It's just donators. Again, use these as a supplement. All right, use hydrogen as a supplement. They can help you get to 8, but you don't want to start with them. Don't start with hydrogens. Those are not going to get 8. Use them where they're needed. All right, so start with these here that are going to get to 8. Start with them. And then when you look at it, you say, okay, well, I've got these 2 oxygens right here. They're going to be similar. It doesn't mean that every single compound with multiple oxygens are going to have the same bonds necessarily. They can, but it's not a guarantee. So when we now come over here to my product side, we need to make a determination. All right, what's going to be the central atom here? What am I building around? And so, you could take, an oxygen in the middle. You could take, a sulfur in the middle, and you could play with it and see how it works. But in this case, I'm going to put my sulfur in the middle here. I'm going to put my sulfur right here in the middle. And go ahead and throw my electrons on there. So 1, 2, 3, 4, 5, 6. And then I'm going to flank this sulfur with my 2 oxygens right here and right here. Okay, so now we're going to get into, we haven't got to our molecular geometry yet with our exact angles and all that. So, and I could show you also if you wanted to put an oxygen in the middle. But for right now, let's start with the sulfur. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so now, as always, we're going to have to start with a single bond, and we're not trying to put multiple bonds at once and all this. Let's just pick one. Let's just pick these 2 right here, and just start somewhere. Don't freeze up and not know where to start and then say, I can't do this. Just start somewhere. You can always erase. You can always go back. We already have 1 electron right there. I'm going to erase this one, and I'm going to go up and put that right there. And I'm going to start with my single bond right there. All right, count them up. Let's do it. Just follow the process. 1, 2, 3, 4, 5, 6, 7. All right, I'm close. 1, 2, 3, 4, 5, 6, 7. I'm pretty close on that as well. So let's go ahead and throw another one up here. All right. So one right here, bring this over right there, bond it up. Okay, so let's count it up. 1, 2, 3, 4, 5, 6, 7, 8. Oh, great. I'm golden right there on my oxygen right there. So now I come over and I look at my sulfur. 1, 2, 3, 4, 5, 6, 7, 8. I'm golden on that one as well. But there's a problem. So now I'm looking over at my oxygen and I'm thinking, wait a second here. Uh, I don't have anywhere to bond this because this has 6. And I'm like, well, 1, 2, 3, 4, 5, 6, 7, 8. I'm already satisfied with these two right here. Where does this go? Okay. And you think, well, I've got my hydrogens over here. I can throw it up there. Well, that's great. I mean, yeah, you could throw, a couple hydrogens and make water with that. But what does that have to do with these two right here? It's no good, right? So we know that, hey, we can't go that route. All right. And again, this just accentuates how Lewis dot can be a give and a take, a trial and error type thing. So what do? We just revert back. We revert back from where we came from. So let's go back. Let's put that up right there. Let's return our electrons there and make sure that you've got that all straight now. The oxygens have 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So we're still good. Okay. So at this point, say, okay, well, it's not going to be a double bond here. So let's go over now and look at this other bond between the sulfur and oxygen and see what we have there. Okay, and don't forget, we still have those hydrogens as a supplement here. Okay, we can still use those. So we come over and we say, all right, let's do let's get a single bond going over here, this sulfur and this oxygen. So I'm just going to move that electron down there out of the way. All right, I've got my electron here. I'm going to take my first electron here and I'm going to come over and I'm going to put it right there and I'm going to circle my bond. Okay. So now where are we at? Let's recount them. 1, 2, 3, 4, 5, 6, 7 for oxygen. I'm at 1, 2, 3, 4, 5, 6, or excuse me, 1, 2, 3, 4, 5, 6, 7, 8. So my sulfur is actually handled. Okay. My sulfur is good to go. It's great. Come back over to my oxygen. 1, 2, 3, 4, 5, 6, 7. So one of the 3 that we have in front of us, not including the hydrogens, is solid. It's ready to go. So this is the great part. This is why we saved our hydrogens for last as a supplement, right? We saved them so we could use them as needed. All right. So now, since we're at 7 for both of our oxygens right here, and we have 2 hydrogens right here, that's where we insert them in, right? And we know that hydrogens is only going to form a single covalent bond here. All right. And really polar covalent, although we haven't gotten that far, guys, but that's essentially what it is. And so now we're going to bring that in. So let's bring in one of our hydrogens. Okay. I'm just going to take this right here and I'm going to move it down here. And don't worry about the angles for right now. We'll get there. All right. So I'm going to bring my hydrogen in. All right. And I'm going to get me a bond going right there. Okay. Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, golden. Okay, we're good. All right, so remember, hydrogen does not need 8. So we have 1 left over here. So let's bring our last hydrogen down and in. And I'm kind of running out of room here. I think I might be out of frame over there. So I'm just going to put it down here for sake of simplicity. All right, I'm going to put it right there. I'm going to circle that bond up right there. And now I'm going to count them up. 1, 2, 3, 4, 5, 6, 7, 8. Boom. All right, so again, let's check all of them. Let's check all of our atoms within this compound. So we've got, for starting with this oxygen right here, 1, 2, 3, 4, 5, 6, 7, 8, good. 1, 2, 3, 4, 5, 6, 7, 8, sulfur, good. 1, 2, 3, 4, 5, 6, 7, 8, oxygen, good. And our hydrogens aren't going to have 8. All right, last check. Do we have 20 electrons total in this whole thing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and we do, and we're good. Okay, so the process there was a little bit longer because we had more atoms that we were dealing with and more in different elements. So the process though is awesome that you guys get to see like a trial and error, but it's okay. It'll take you a little time until you can start seeing these bonds like, oh, wait, I can mathematically start looking at these electrons in my head and start thinking to myself, all right, I know this is going to be a double bond or whatever, then just take it step by step and you can erase and you can go back if needed. All right. So hopefully this will help you guys. Keep going through your notes, go through your foldable that we did, go through all your resources and get some reps in, and you'll be good. All right, guys.